The 4th of July weekend in 2025 was supposed to be a time of joyous celebration in Central Texas, a moment to reflect on freedom and community. Families had planned barbecues, parades were scheduled, and the air was thick with anticipation for the fireworks displays that would light up the night sky. But instead, it became a desperate fight for survival against the relentless forces of nature. What began as a promising holiday quickly devolved into a crisis, testing the limits of human endurance and community resilience. Instead of the dazzling bursts of fireworks painting the night sky, the ominous roar of flash floods echoed through the usually tranquil valleys of the Texas Hill Country. The sounds of celebration were replaced by the urgent cries for help and the deafening rush of water. The unprecedented rainfall transformed the picturesque hill country into the epicenter of a historic disaster, leaving a trail of devastation in its wake. Homes, businesses, and entire communities were submerged, forever altering the landscape and the lives of those who called it home. The Guadalupe River, usually a gentle, meandering waterway, a source of recreation and natural beauty, became a raging, uncontrollable torrent, fueled by the torrential downpours. Its banks overflowed, and its currents surged with destructive power. The swollen river swept away homes, businesses, and infrastructure, cutting off entire communities from the outside world and leaving residents stranded and vulnerable. The floodwaters left behind a scene of unimaginable destruction. This wasn't just a typical heavy rainstorm that Texans are accustomed to. It was a relentless, multi-day deluge, an atmospheric river that stalled over the region, overwhelming every flood defense and shattering records for rainfall intensity. The ground became saturated, and the rivers and creeks swelled to unprecedented levels. Emergency responders, stretched to their limits, scrambled to rescue people from rooftops and stranded vehicles, as neighbors selflessly helped each other escape the rising waters, demonstrating the true spirit of community in the face of adversity. Acts of heroism and compassion emerged amidst the chaos. The immediate focus now is on saving lives, providing emergency aid to those affected, and ensuring the safety and well-being of the displaced. Shelters have been opened, and volunteers are working tirelessly to provide food, water, and medical assistance. But worryingly, more rain is in the forecast, threatening to trigger another round of devastating floods and further complicate rescue and relief efforts. The threat of additional rainfall looms large, casting a shadow of uncertainty over the already devastated region. How did this happen so quickly, catching so many off guard? What combination of factors led to this catastrophic event? We'll break down the complex science behind the storm, examining the atmospheric conditions that fueled its intensity, and explore the unique geography of the Texas Hill Country that made the flooding so much worse. By looking at past flood events in the region and analyzing the current weather forecast, considering both short-term and long-term trends, we can begin to understand the ongoing risks still facing the resilient people of Texas and the challenges that lie ahead in the recovery process. The road to recovery will undoubtedly be long and arduous, filled with challenges and setbacks, but understanding the underlying causes of this disaster is the crucial first step towards building a more resilient future for the communities of Central Texas. To grasp the force of the July 2025 Texas floods, we need to look at the atmosphere, where three powerful ingredients combined for disaster. First, a slow-moving upper-level disturbance parked over the hill country, pulling in moisture and creating instability. This system generated massive thunderstorms, wringing out every drop of moisture over the same area for days. Second, deep tropical moisture blanketed Texas, acting as high-octane fuel for the storm. This wasn't just surface humidity. It was a deep layer of moisture, providing endless fuel for the developing storms. Third, the combination of this lifting mechanism and rich moisture made the storm system incredibly efficient at producing extreme rainfall. The atmosphere was primed for a historic event, and all the necessary components locked into place over one of the most flood-prone regions in the country. The result, a tragedy that unfolded with terrifying speed. A key player in this disaster was the lingering moisture from Tropical Storm Barry. After making landfall in Mexico, Barry's remnants streamed north, sending a river of tropical moisture straight into Texas. This saturated the atmosphere, making it primed for heavy, persistent rain. When the upper-level disturbance arrived, it squeezed this moisture out, unleashing a deluge over the hill country. This pattern, where remnants of a tropical storm fuel inland flooding days later, is a classic Texas scenario. Even after losing its name, Barry's influence was profound, turning a significant rain event into a historic flood. The people of the hill country faced the far-reaching consequences of a storm that had made landfall in another country nearly a week earlier. It's a powerful reminder of how interconnected our weather systems truly are. The third critical element was a low-level jet stream, a fast-moving ribbon of air just above the ground. Originating over the Gulf of Mexico, it acted like a fire hose, funneling warm, humid air directly into the hill country. This relentless conveyor belt kept refueling the storms, allowing them to regenerate and dump rain over the same area. This process, called training, led to catastrophic rainfall totals. The low-level jet ensured the storm's engine never ran out of fuel, transforming heavy rain into a prolonged torrential downpour. The combination of the upper-level low, Barry's moisture, and the low-level jet created a worst-case scenario. Each factor amplified the others, resulting in a perfect storm that overwhelmed the landscape. The hill country simply couldn't handle the continuous assault of tropical moisture. The disaster wasn't just about the sheer volume of rain that fell from the sky. While the rainfall totals were staggering, the devastation was compounded by another crucial factor. It was about what happened the moment that rain hit the ground, and the unique characteristics of the land itself. The way the water interacted with the terrain played a pivotal role in the unfolding catastrophe. The Texas hill country's steep hills, while picturesque, are a major contributor to the region's flood risk. These inclines create rapid water flow. The rocky terrain, composed largely of limestone, further exacerbates the problem. This type of rock is not very porous, and the thin soil, often just a shallow layer over bedrock, offers little opportunity for absorption. The ground is simply unable to soak up significant amounts of water. These factors combine to make it one of the most flash flood-prone areas in North America. The region is essentially a perfect storm of geological and topographical conditions that amplify the risk of sudden and severe flooding. Rain can't soak in. The earth is almost impermeable. It runs off instantly, as if falling on concrete. There's no gradual absorption, no slowing down of the water's relentless journey downhill. Water rushes down hillsides, gaining momentum and volume with every passing second. It's then funneled by canyons, which act as natural channels, concentrating the flow and increasing its speed. And dry creek beds, which appear harmless under normal conditions, become raging torrents in minutes, transforming from peaceful gullies into destructive forces of nature. Nearly every drop of rain becomes runoff, contributing to the rapidly escalating floodwaters. This runoff is channeled with incredible speed toward rivers like the Guadalupe, overwhelming their capacity and causing them to overflow. This is why flash floods here are so sudden and violent. The water has nowhere to go but down, and it does so with incredible force. Because of the speed at which these floods develop, there's almost no warning. Residents often find themselves facing a wall of water with little or no time to react. When record-breaking rainfall hits this unforgiving landscape, the consequences are predictable. Catastrophe is guaranteed. The region's vulnerability is simply too great to withstand such extreme weather events. In Streator, Texas, over 20 inches of rain fell in a short period. That's an unimaginable amount for land designed to shed water, not absorb it. The ground was already saturated, and the deluge simply had nowhere to go. The result was that rivers exploded out of their banks with terrifying speed and power, unleashing a torrent of destruction upon the surrounding communities. The hill country's beauty hides a dangerous secret, a vulnerability that can turn paradise into peril in a matter of hours. Its geography is a recipe for disaster, a combination of factors that makes it exceptionally susceptible to the devastating effects of flash flooding. When intense rain, the kind that seems to fall straight out of the sky in sheets, meets the hill country's funnel-like terrain, a landscape sculpted over millennia to efficiently channel water, the consequences can be dramatic. This unique topography acts as a natural amplifier, concentrating rainfall into ever-narrowing valleys. Rivers rise with explosive speed. What might start as a gentle stream can transform into a raging torrent in a matter of minutes. The Guadalupe River surged 26 feet, an almost unbelievable rise in just 45 minutes, a rate of ascent that defies comprehension and underscores the sheer power of these flash floods. It was a vertical wall of water, a churning mass of debris and raw energy, hurtling downstream. Residents had almost no time to react, caught completely off guard by the suddenness and ferocity of the deluge. Before the floodwaters arrived, sweeping away everything in their path and leaving a trail of destruction in their wake. This is the hallmark of a hill country flash flood, a terrifying display of nature's raw power. The water doesn't creep up, giving you hours to prepare. It surges with devastating force, an unstoppable wave that leaves little room for escape. The sheer volume of water, billions of gallons, cascading through these narrow corridors, overwhelmed the river systems, exceeding their capacity and spilling out across the surrounding landscape. Even a single inch of rain over an acre equals 27,000 gallons, a staggering amount of water. Now imagine over a foot falling across the region, the equivalent of countless swimming pools being dumped onto the land in a matter of hours. The rivers, usually peaceful, meandering through the countryside, became deadly torrents, transformed into raging rivers of destruction. They were no longer life-giving waterways, but destructive forces, destroying everything in their path. The 2025 flood is a stark reminder, a brutal lesson in the power of nature and the vulnerability of our communities. These rivers are not just scenic features, they are part of a dynamic, dangerous system capable of unleashing immense power. The speed, the sheer velocity of the water, volume, the unimaginable quantity of water surging through the region, and force of the water, the relentless crushing power of the floodwaters, created a catastrophe, a disaster of unprecedented scale. It was a cataclysmic event that changed lives and landscapes forever, leaving an indelible mark on the region. In the hill country, a place of beauty and tranquility, nature's power can be unleashed in an instant, reminding us of the forces that shape our world and the importance of respecting their potential. For many Texans, this July flood brought back memories of the 2015 Memorial Day disaster on the Blanco River. That event saw the river rise 45 feet in an hour, killing 13 and destroying hundreds of homes. The 2025 Guadalupe flood echoed that tragedy. Similar rainfall, a rapid river surge, and a stalled weather system fueled by tropical moisture. These aren't once-in-a-lifetime events, but recurring threats for the hill country. The lessons from 2015, about warning systems, emergency response, and the dangers of building in floodplains, are being tested again. For the Guadalupe communities, this is their defining flood, a benchmark for all future disasters. Even as floodwaters recede, the danger isn't over. Central Texas is still at risk. The ground is saturated, any new rain will run off immediately, triggering more flash floods. The same weather pattern lingers with showers and storms in the forecast for days. Now, even half an inch of rain could cause dangerous flooding. The forecast calls for 2 to 4 more inches in the hardest-hit areas, with isolated spots possibly seeing up to 10. Emergency managers and residents must stay on high alert. Another wave of flooding is very possible. This ongoing risk complicates rescue and recovery efforts, as roads and communities could be reflooded at any moment. For everyone in the region, vigilance is essential. Heed warnings, stay informed, and never cross flooded roads. The ground is primed for more disaster. Caution is the only defense. The long-term risks from this historic flood are serious and far-reaching. Saturated ground means rivers and creeks will remain sensitive to any new rain for weeks. Floodwaters have left behind a toxic mix of debris and chemicals and contaminated mud, a major public health hazard. Cleanup will be massive and dangerous, requiring protective gear and caution. The ground's stability is now in question, with increased risks of landslides and weakened infrastructure. Roads and bridges may be compromised, and inspections will be critical before communities can safely reconnect. Recovery will be long and difficult, involving not just rebuilding but healing from deep emotional scars. As the hill country begins to recover, the saturated ground and swollen rivers remain a constant, potent danger.